Hello there everyone, it is KP the Math G, and we are working with indefinite intervals. This is the 41st video, and I do appreciate you tuning in to it, and hopefully I trust that you can get something out of my videos. And anyway, let's go ahead and begin. We're dealing with finding particular solutions for C. You might have a problem after you integrate. And I say after you integrate, you come up with something that looks like this. Y is equal to 2x squared minus x plus C. Something like that. And then we're going to figure out what C is. Okay. This is a parabola that has several different, this thing could be moved in several different ways, but we want to find a particular place for it. Okay. And that's the idea behind our lesson today. Yeah. So let's go ahead and start with this problem here. Okay. I have so much trouble sometimes keeping one of the magnets wants to fall out of this eraser, and I have a little trouble with that. And my eraser doesn't want to stick to the board anymore. Okay. But anyway, let's go ahead and start. Okay. We'll write this problem down. Okay. All right. I'm going to say this. I should have had this already written up here. So, that's a little light, isn't it? So let's get a little darker than that. That looks a little bit light. Maybe we'll get started before too long. Here we go. Let's try it. We want to find an equation. And we're looking for an equation of the curve. That passes through passes through 1, -3, and the slope at any point xy is 3x squared Now that represents the slope. Alright, and this slope, by the way, is a ratio, rise over run. You've been familiar with that, haven't you? It is a rate of change, isn't it? Alright, so when we take this antiderivative, we're going to come up with an equation. But first, we're going to come up with some c at the end, as we always do. So let's take the antiderivative of this, 3x squared plus 4x and dx. Okay, let's do that. Okay. If we do that, then we're going to find that our answer is equal to, now 3x to the third over 3. Alright, remember we're adding 1 to our exponent and then putting that answer down in the denominator. Alright, same thing here. 4x This is a 1. Add 1 to it. We have 2. Now plus c. Okay, I'm going to rewrite this problem now. And then we're going to say now, in this particular case, we're going to say, well, let's make this our equation. Y is equal to x cubed, because remember the 3's will divide out. 4 divided by 2 is 2, so plus 2x squared plus c. Alright, that is the general equation. Because it's general because it has a c attached to the end of it, doesn't it? Alright, so now it passes through 1, 3, where x is 1 and y is 3, or negative 3 rather. So let's plug those numbers in. Negative 3 is equal to 1 cubed plus 2 times 1 squared plus c. Notice immediately that c is going to be by itself when we get through solving for it. Alright, so here it is. Negative 3 is equal to 1. 1 cubed is 1. 1 squared is 1. 1 times 2 is 2. Alright, so 2 plus c. Negative 3 is equal to 3 plus c. Then when I subtract 3 on both sides, here we have c equals negative 3 plus negative 3 is negative 6. So, in place of this c right here, we're simply going to put negative 6 right here. So now, instead of c, it's going to be negative 6. And that is our particular solution. Okay, I think in my last video I said c could be 1 or 2 or 3 or negative 1 or negative 2, negative 3. And in this case it's negative 6. Okay, so that's what we're doing now. Okay, that's the idea. Now sometimes we are going to find 2 different c's, okay? And each time we're going to make our equation a little bit bigger and a little bit bigger. But that's for the next lesson, okay? Let me do, I think I have one more problem. Yeah, I do. Alright, so let's do this one. We might can just flip this over and save some time doing that. Get my eraser first. Okay. Alright, now let's put our eraser back up there. See, it stays. How about that? Alright, so here is a problem also. Given that f prime at x is equal to cosine x, and we have what you call an initial condition. I should have said that from the last time. An initial condition. Initial condition. Alright, well, what is that initial condition? Well, it is f at pi over 2 is equal to 5. That's the initial condition. Alright, we're going to find a c such that f at negative 2 equals 5. Okay, that's what we want to do. We want to find the value of c. There's a rule that says that if I'm going to take this antiderivative of both sides, but it's like this. If I take the antiderivative of some derivative, well, we'll talk about that in just a little bit. And we're going to do that just like that. See? Alright. Now, if I take the antiderivative of a derivative, it's just going to take that off. See, that's f at x. And we're going to just say the plus c. We're going to reserve the plus c for on this side of the equation. Okay. Alright, so this is this. Okay. Alright, now remember from the last video, the antiderivative of cosine is sine x, and now plus c. Okay, that's what you do. Let's just kind of do a little something here. I'm going to show you off to the side. If I have f double prime at x, when I take that antiderivative, well, that's equal to f prime at x plus c. And then, of course, if I take the antiderivative of f prime at x dx, then that's equal to f. Well, I keep wanting to do my integration symbol. F at x plus c, and that's what I did here. Alright, that's f at x. Okay, and that's kind of what you do there. Alright, it's kind of like if you take the antiderivative of acceleration, you get velocity, and when you take the antiderivative of velocity, you get the distance, okay, the distance equation, or the position equation. Alright, so here we are. We've got this. Now I can do the f at 2. See, this is f prime. This is f. So I wanted f. So now f at pi over 2 is sine pi over 2 plus c. Oh, Jiminy Cricket, what is sine pi over 2? I don't know. Yes, I do. If I draw the picture or the graph of sine, remember the graph of sine looks something like this, and it starts at 0. This is 1. This is -1. This is pi over 2. Pi is at 0. 3 pi over 2. Where is that? -1. The y value is -1. I'll move my -1 up here. Okay, and then this is 2 pi, which is back to 0, isn't it? So right here at pi over 2, we're at 1. Okay, so sine of pi over 2 is 1. Now, again, it helps to memorize this, if you can possibly memorize that. So now we have f at pi over 2, which, by the way, is 5. So I'm going to substitute the 5 in place of f at pi over 2. This we know is 1 plus c. Now I'm going to subtract 1 on both sides, and we'll have c is equal to 4. Alright, so c, let me erase this now. Alright, so c is equal to 4. So that means that, yeah, right here. Get a different color. Maybe we can get something if we don't have the exact same color all the time. Alright, here we go. Let's plug it in now. Let's plug in the c right here. Alright, so now you don't plug in the pi over 2 again. You just leave the x's alone. So f at x, let's put it right down here somewhere. F at x is equal to sine x. Now the only thing you are filling in is plus c, which is plus 4. And that's a more specific, right, a particular solution now. Because it's particular because we don't have a general solution. We now have a particular number. It's 4. So what happens to this sign? The graph of sine, it goes up 4 units from where it was originally. Okay, that's what happens here. Alright, so there it is. And again, with this equation, once again, C could be 0, 1, 2, 3, 4, 5, 6, 7, 8. C could be -1, it could be -1.5, -2, -2 and 1/3 or something, -16, whatever. But in this case now, we have the initial condition, f at pi over 2 is equal to 5. With that condition, we come up with 4. Well, 4 plus 1 does equal 5, doesn't it? Okay. Alright, that's pretty much all I wanted to show you. In the next video, I'm going to have one where you have to fill this out a couple of times. And I got a couple examples for that. So I'm looking forward to doing this on my 42nd video. But I hope this has been helpful to you. Think about the words and phrases that you're seeing here in initial condition. Look for that. Alright, see what that initial condition is. Don't do anything with it until after you find the antiderivative and put that plus c on the end. Because if you don't put the plus c, you're not going to know what this means. Okay, and then plug in. This by the way. This by the way was like that last problem. This is your x, and this is your Lfet x. All right, or y, which is y. Okay, so this would be an ordered pair of pi over 2, comma 5. Alright, so that's what you need to kind of keep in mind. Alright, on the flip side of this one, the initial condition could have looked like this. Instead of going through the 0.13, the initial condition could have said, well, we want, and we could have said y, Lfet instead of y or g or whatever. We could have said Lfet 1 is equal to -3. So keep in mind, you could see either this or you could see this. Okay. Alright, so that's what I had in mind. This is what we have here. We have the initial condition. Again, either way, it could be written. Alright. Alright, so that's it. Once again, this is KP the Math G. Again, don't forget to hit that subscribe button. If you have a comment, please feel free to make a comment. If there's anything that I could have done a little better, I'm open to suggestions. If you like the comment, you can hit the like, or if you like what you just saw, do that too. So anyway, KP the Math G signing off for now. You have a great day.